Hello, my name is Lillie Whitten, and I'll be presenting on behalf of myself and Clay Baker for our final project. So I will be sharing my screen to show our presentation. So we decided to do a Simulink analysis of Lanchester square laws in simple warfare for our report and video and final project. So in summary, the mortality rate of fire ant Solenopsis invicta can be modeled by Lanchester's square model, which states that the success of a group in combat is proportional to the square of the number of members within the group and only linearly proportional to the fighting ability of members within the group. In the system we have modeled, we are using the collective skill of each group and the number of members of each group. This can be easily modeled by the equations below. This is essentially a predator-prey model that has been modified to consist of two predators that will eliminate each other. The equations I mentioned in the summary before are shown here, where the derivative of A equals the skill members of B times the number of members in B, and then vice versa, the derivative of B equals the negative skill members in A times the number of members in A. So the results from our first variation, in this situation, we had Group A set to 600 members in a combat skill of 0.01, and Group B set to 300 members, but having a combat skill of 0.05. As you can see, Team A is in blue, and Team B is in this orange color. And the winner in this scenario was B because the ratio of skills is greater than the square of the ratio of group members. In our second variation, we set Group A to 600 members in a combat skill of 0.01. And in Group B, we still had it set to that 300 members, but we decreased their combat skill to 0.01. And the winner in this scenario was A because the ratio of skills is the same, and the winner was determined based on team members, and Group A has more team members. So the results from the third variation, in this situation, Group A only has 600 members, with combat skills of 0.01, and Group B now also has 600 members and their increased combat skill of 0.05. So in this scenario, the winner was B because the team members are the same, and the winner was determined based on their skill set. So in conclusion, the model demonstrates that once the number of members in one group becomes negative, the other group will increase exponentially. The beginnings of this can be seen in every graph and will become increasingly clear if the sample time was increased. This is because the model is written to show the rate of death of Group A depending on the skill level and number of members in Group B. In other words, the slope of Group A depends on the group number, and once the group number of B becomes negative, the two negatives cancel each other out and the slope becomes positive. And this is our block diagram. As you can see, we have negative 0.05, and we have the integrators in the scope to generate those diagrams that you saw in the presentation. And that's it. And here are our references below. We used Greg Brown's Lanchester square model modeling the Battle of the Atlantic. And then we used Nicola Plow's and Adam Elridge's an imperial test of Lanchester square model mortality during battles of fire ant, Solenopsis invicta. Thank you for watching. Bye.